right. Welcome to another set of Hopefully It Works notes. This is Chapter 8, which is acids and bases, and our notes kind of bounce around in the book, but I've labeled them for you. Section 8.1, in addition to just introducing acids and bases, tells you how to name acids and bases. And naming acids is the one that is a little bit confusing. And there's a summary chart that gives you some examples and highlights the rule. It's on page 287 in the 11th edition of the book and 281 in the 10th edition for those of you using that one. Now, all acids start with H. That was our general definition of an acid. So we have a general format of HA, where A is the anion. Remember, an anion is just the negative ion. So since all of the acids have H, we have to look at the part that is not H. So we're going to look at the A. And depending on what that is going to determine how we name the acid. So if the anion ended in IDE, chloride, fluoride, then the acid is going to be hydro, the root of the word, and then ic acid, so HCl, hydrochloric acid. When the anion ended in ITE, we got the root of the word, and then OUS, acid. And when the anion ended in ATE, we got IC, acid. Just change the ATE to IC. Now, that ite and ate ending, remember, those were the ones that belonged to polyatomic ions. So it's very, very important to know your polyatomic ions. Now, naming bases. It's actually going to be easier. Since bases are just ionic compounds, where the negative ion is hydroxide. So really you just have to worry about what is the name of the metal, because it's just going to be a metal with hydroxide. So things like sodium hydroxide, magnesium hydroxide. You might have those metals that get Roman numerals, in which case you could have something like iron Roman numeral 2 hydroxide. But that's no different than when we named ionic compounds in chapter 4. Now, back on your actual typed notes, hydrogen ions from water. Water splits to a small degree into two ions, the hydrogen ion and the hydroxide ion. So we know water is neutral. Kind of look at it as it's equal parts acid and base. Now that H plus is tiny. It's just a proton. So it actually joins a water molecule or piggybacks onto a water molecule to give us H3O plus, which is called the hydronium ion. So because of that, the equation that I've written there, you can see I've rewritten it in red. Sometimes it'll have two waters on the reactant side, and then it'll be H3O plus on the product side to show that hydrogen ion doesn't really stay alone. Now, we're going to see brackets a lot in here, and brackets has a specific meaning, and it's concentration in molarity, moles per liter. I write H plus in brackets. Your book a lot of times writes the H3O plus in brackets, but their concentration is equal, so it doesn't matter which one you use. Now, since water is splitting into H plus and OH minus, they're interdependent and inversely related. If one goes up, the other one goes down, and their product is always 1 times 10 to the minus 14. That's what I've highlighted in yellow. And you can use this to find one of them when you're given the other one, because all you have there is an equation to solve. So let's do some of those for practice. Okay. H plus times OH minus is always equal to 1 times 10 to the minus 14. So let's say you are given an H plus of 1 times 10 to the minus